Hello students, let us go through one more sums where there are variables in the denominator. The sum is 7x minus 2y upon xy is equal to 5 and 8x plus 7y upon xy is equal to 15. Little different, right? Because normally it used to be like 2 upon x plus 3 upon y is equal to say something, So there were two terms, 2 upon x plus 3 upon y. Now here there is only one term, 7x minus 2y upon xy is equal to 5. 8x plus 7y upon xy is equal to 15. So again something new to learn. What it is? Let's see. The equations given are 7x minus 2y upon xy is equal to 5 and 8x plus 7y upon xy is equal to 15. So the problem here is we are generally used to seeing two terms, 2 upon x plus 3 upon y in all the sums, and then we substitute, resubstitute and all. Here we are only seeing one term. Now how do we solve this? Now you all must be thinking, let's cross multiply, but when we cross multiply you get 5xy, and xy, you remember, it's not a linear term. So what do we do? Now see, this is how you need to think. There are, there is only one term here, 7x minus 2y upon xy, right? This is what is given to us. What we want is, we want two terms. We want upon x term and upon y term, right? So what we need to do is, we need to split this one term into two so that we get our normal sum, right? Now how do we split? Now see, this denominator xy is applicable to both 7x as well as 2y. This denominator xy is applicable to both the numerator 7x as well as 2y. So let us separate it. Let us separate 7x, let us separate 2y, but the denominator xy will go with both the numerators. Just show you how. Now see, what we need to do is, this xy is for both. So what we do is, we separate 7x and xy. So here xx would get cancelled, 2y upon xy. Here yy will get cancelled, right? So now we got two terms. Now see, here xx gets cancelled. So what we get is 7 upon y. Here yy gets cancelled. What we get is 2 upon x is equal to 5. Always in the alphabetical order. So let's write minus 2x first. Don't change the sign because you're not changing the side. You are just rearranging to write it in the alphabetical order, right? So minus 2 upon x plus 7 upon y is equal to 5. Now look at this equation. Don't you feel this is normal sum that we have learnt where there are variables in the denominator? So this is how you need to think in the exam. There is only one term, we need two, so let us split. The only care that you need to take is the denominator will go with both the numerators as we did in this step. Clear? Let's repeat the same for the second equation as well. You will get 8x upon xy plus 7y upon xy, splitting, right, is equal to 15. Xx gets cancelled, you get 8 upon y, yy gets cancelled, you get 7 upon x is equal to 15. Now rearrange to write it in the alphabetical order. Rearranging, you should not change the sign because you are not changing the side, you are just rearranging in the left hand side, right? So you get 7 upon x plus 8 upon y is equal to 15. Let this be the second equation. Now see the two equations, normal simple equations where you have xx in the denominator, you have yy in the denominator, so you need to substitute 1 upon x as m and 1 upon y as n, right? Minus 2 upon x can be written as 2 into 1 upon x, 7 upon y is actually 7 into 1 upon y. 7 upon x is 7 into 1 upon x and 8 upon y is 8 into 1 upon y. So now let's substitute 1 upon x as m and 1 upon y as n in equation 1 and 2. So when you do it in equation 1, you get minus 2m plus 7n is equal to 5, something which we already know. Second equation, you get 7m plus 8n is equal to 15. Let this be equation number 4, right? Now let's solve the two equations by the method of equating the coefficients. We already know the method, so let's quickly rush through it. Look at the coefficients of m. The coefficients are minus 2 and 7. The coefficients are not same. We cannot eliminate m. Look at the coefficients of n. The coefficients are 7 and 8. Again, the coefficients are not same. We cannot eliminate n. So what do? We either make the coefficient of m same or we make the coefficients of n same. Just take some time, look at both the coefficients, look at the coefficients of m, look at the coefficients of n. We feel it is better to make the coefficient of m same, right? Just that you cannot make 2 as 7 or 7 as 2. So, you need to take the LCM and make both 14. 2 and 7, the LCM is 14, right? And for doing that, you will have to multiply the third equation by 7 and you will have to multiply the fourth equation by 2, right? So, let us multiply the third equation by 7. You get minus 14m plus 7 into 7 is 49n is equal to 5 into 7, that is 35. Let this be the fifth equation. Now, let us multiply the fourth equation by 2. We get 7 into 2 is 14m, 8 into n is 16n, 8n into 2 is 16n, and 15 into 2 is 30. That is your equation number 6. Now, look at the two equations. We have got the values, the coefficient of m as same. So, you can eliminate m, and for that you will have to either add or subtract, and that we need to decide by looking at the signs. So, in the fifth equation the sign is minus, in the sixth equation the sign is plus. The signs are different, and whenever the signs are different we need to add the two equations. So, let us add equation 5 and 6. That is your fifth equation, that is your sixth equation. Let us add. Now, when we add minus 14m plus 14m will get cancelled. 49 plus 16 will be 65 and 35 plus 30 is also 65. 65n is equal to 65. So, n is definitely equal to 65 upon 65, that is 1. Once you get the value of n as 1, now it is time for us to find the value of m by substituting n is equal to 1 in either of the two equations. Let us substitute in equation number 4. We get 7m plus 8 into 1 is equal to 15. We get 7m plus 8 is equal to 15. We get 7m is equal to 15 minus 8. We get m is equal to 7m is equal to 7. So, m is equal to 1, 7 upon 7. You got the value of m as 1. You got the value of n as 1. Now, it is time for us to resubstitute the values of m and n. How do we resubstitute? 1 upon x was substituted as m. So, now m will be resubstituted as 1 upon x and m is equal to 1. So, we can say 1 upon x is equal to 1, right. 1 upon x is 1, and similarly 1 upon y is equal to n, and n is also equal to 1. So, 1 upon y is also equal to 1. 1 upon x is 1, 1 upon y is 1. Now, let us take the reciprocal to find the values of x and y. You get x is also equal to 1 and y is also equal to 1. X is 1, y is 1. Just write the final answer that the solution of the given simultaneous equations is x comma y, that is 1 comma 1. As simple as that.